We're learning today how to calculate the missing height in a triangle and then calculate the area of the triangle. So we need to find the missing height and then calculate the area of this triangle. At first, you must read the question and you place the given numbers on the drawn diagram. So they're telling you that B, which is CA, so we can read it side CA, or AC, which is side B, is actually equal to 11 centimeters. So here we go. We place the 11 centimeter here. And A, which is side CB or side BC, or we call it side A because it is right across. So if this is angle A, so this is the side that is opposite to it. We're looking now at triangle ABC and we ignore this line in here, which is BD. So if this is angle A capital, the opposite side to it is BC or CB, which is small a. Now, as we specified B small, or it is actually there in the question, we just located the given number next to it. So this one, like I said, we ignore line BD. So the opposite angle to side small b is this angle, which is B capital, and it is unknown. Now, side A, which is 9 centimeter, and the opposite angle to side A is this angle. So this is A capital. Now, C capital is actually equal to 35 degrees. So BA is the opposite side to angle C. So this is C small, which is unknown. Now, if we look at this question, we have a known side and another known side here, and there is an angle in between. So we must think about using the sine rule or the cosine rule. This angle here is 55. How do we know? If we take triangle BDC, we always name the triangle or the right angle triangle with the 90-degree angle in the middle. So we name this triangle as BDC or CDB. So if this is 90 and this is 35, the sum of angles in a triangle is equal to 180. So if we add the 90 and the 35 and we subtract the total from 180, so this angle must be 55 degrees. Now, if we take again triangle BDC, which is as well triangle CDB, and we apply the sine rule on it. So, side BC over the angle that is opposite to side BC is this angle, which we name it as angle BDC or CDB. So sine of BDC. So side of BC over sine of angle BDC is equal to, we need to write three fractions in the sine rule, over side BD, the opposite angle to it is this angle. How do we name it? So we say sine of BCD or DCB. The third side is CD. So side CD over the opposite angle to it is this angle. And how do we name it? We name it CBD. So we say side CD over sine of CBD or sine of DBC. Let's substitute. So side BC is actually equal to 9 centimeter over sine angle BDC, so sine of 90. Then BD is actually equal to H, so we're going to replace it with H over sine of 35 is equal to, side CD is unknown, so it's gonna stay as CD over sine of angle CBD, which is 55. So here we go. BC is equal to 9 over the opposite angle to side BC is this angle here, which is 90. So sine of 90 is equal to BD is equal to H. So we place BD with H over the opposite angle to side BD or side H is the 35. So sine of 35 is equal to CD is unknown over the opposite angle to side CD is 55. So sine of 55. Now, we want to find the height. The base is already known, which is 11 cm, and we need to find the height. So we're going to ignore the third fraction and we're going to take the first two fractions as following. And then we're going to apply the cross multiplication. So cross multiplication, H times sine of 90 is equal to 9 times sine of 35. Or we can cut it short. We say, what is my unknown? H. H is equal to and fraction line. What is the H multiplied by? It is multiplied by sine of 90. So sine of 90 goes down as the denominator. The other two numbers, which are 9 and sine of 35, are going to go up as numerators multiplied by each other as following. Now this is ready to be inserted in the calculator, and if you do so, you're gonna end up with H is equal to 5.16 centimeter, because all dimensions or all the lengths in this triangle are given to us in centimeters, and the answer is correct to three significant figures. So 5 is the first figure, 1 is the second, 6 is the third. So you stop at 6 and you look at the right. 2 is not going to bring my 6 up, so the answer is going to stay as 5.16 centimeter, correct to three significant figures. So now we have this triangle. We found in the previous step H, which is side BD. The base is known, which is side CA, and the general formula of finding the area of any triangle is half times base times the perpendicular height on the base. The base is 11, so we're going to substitute now. So we wrote the general formula, and now we're going to substitute the base and the height in the formula. What is the base? The base is 11. What is the perpendicular height? It's 5.16. Let's do that. So it's half times 11 times 5.16. Now this is ready to be inserted in the calculator, and if you do so, you're gonna end up with the area of triangle is equal to 28.4. 28.4. 2 is the first figure, 8 is the second, 3 is the third. Stop at the 3, look at the right. 9 is gonna bring my 3 up to 4. So the final answer is 28.4 centimeter squared. And remember, the area is always calculated in millimeter squared, centimeter squared, meter squared, etc. And this is the area of the triangle. So the base was given to us, the height was unknown. So we found the 35 was given to us. We found the angles that we can find based on the given angles. And then we took part of the triangle, because as you can see here, we can see 1, 2, and 3 triangles. CDB is one triangle, ADB is the second triangle, ACB is the third triangle. So we took CDB to calculate the height using the sine rule, and then we just wrote the general formula of finding the area of a triangle. We substituted the base and the perpendicular height, and then we found the area of this triangle. I want you to think of this question, which is basically very similar to the one that we solved. Please try to solve it on your own and watch this video more than once if you are still struggling with any of the steps. And always remember that practice makes it perfect. Thank you for watching, sharing, and subscribing to my